benefits and use cases for flash storage.
Thank you, Neil. So today, I apologize, my screen when I click in. There we go. Today I'm going to talk about the business benefits and use cases. So first of all, I'm going to start off with just the overall impact of flash itself. Flash can have a few different impacts from a business perspective, higher performance, reducing costs, and even enabling green IT. And these are very different ways of using flash inside the industry. Different outcomes, different drivers. So you really have to understand what you're trying to get at when you go into a flash component. There's really no one-size-fits-all flash solution, at least at this point. And I'll get into some of those details. And if you look at it from an application perspective, I think there definitely is a one-size-fits-all. But if you look at potentially an enterprise large amount of capacity with various different applications, it's tough to have a one shoe fitting everything there. So the adoption of flash, first of all, the first question there is a huge one. Is the spinning drive dead? Right, and that's something that there's a lot of opinions in the industry on the spinning drive as of today. Anything from, it's on its way out in the next 5 years to it's going to take a long time before that is no longer in play. And I think it's going to be somewhere in between. Right? There are aspects of the spinning drive, the 10K drive, the 15K drives of SAS technology are definitely roadmap to be over with soon. But what's going to stick around for a while is going to be the SATA, the larger drives that will be here. And those SATA drives, the multi-terabyte drives, have kind of a different workload that they will fulfill. But as we go through this, we're seeing that there's a lot more of those workloads that are moving closer to the flash side of things. With that being said, there's a lot of applications now that are being written with flash in mind for the back-end storage and anticipating the higher throughputs and the low latency qualities of flash in the application itself. Price is becoming more affordable. So as we see the actual cost per gig on flash, although it's much, much greater than what it is on spinning drive technology today, that gap is becoming less and less as we go through this. And some of those factors are consumer products driving flash in the mainstream. You see my point here that cell phones are the #1 use for flash right now for all flash technology. And the benefit of the storage industry as a whole from that is that these consumption-based models of flash technology helps in the manufacturing cost to drive that down for a benefit of the overall flash industry itself. There are also some market dynamics that are affecting this other than the consumer aspect of it. We look at the advancement in servers. So Intel with the new Haswell processors with more cores, more processing, there's more opportunity to drive the higher CPU utilization, kind of moving the bottleneck from the CPU potentially over to storage. And flash is a major contributor to driving more IOPS from that perspective. Another one is virtualization. So virtualization is everywhere. It's implemented in every application from the high end to the very low end. And what that does is it kind of gives you an unpredictable I/O pattern. They call it the I/O blender. So a different I/O pattern back at the disk subsystem. It's harder to design an architecture to assume what you're going to get from the I/O and what the requirements are. So flash is kind of an easy button from that perspective to say, hey, if I need really, really high I/O and low latency and I don't know what's coming, it's an easy way of putting a tier in there to be able to accommodate the virtualization there. And finally, there's the applications that are being written that will actually need to have flash storage in the background. And a lot of those are database driven. A couple here are listed. But they're written with the assumption that there will be a low latency environment from an I/O perspective. And this can be utilizing either RAM in some of the solutions from SQL Server, or assuming that there's going to be a flash disk behind it to keep the latency numbers low. So workload should actually determine the storage technology. It's not so much the other way around that we're going to go and say, hey, I'm going to develop my storage so that my workloads work. It should be, what do I have for workload patterns, I/O patterns? So some of these patterns might result in an all-disk array. An example of this might be some long-term, high-capacity data that needs to stick around, but not necessarily have any SLAs around the type of access to it. So if it takes a second or a few seconds to access that type of data in that storage tier, that's totally acceptable. And you usually see a lower cost per gigabyte of disk arrays, but it really is for a specific type of workload. After the all disk arrays here, we have hybrid arrays in the middle. Hybrid arrays are allowing for kind of an in-between, between the, hey, I've got an OLTP database, but I need incredibly low latency numbers, to all disk that really has no access time requirements. Hybrid arrays kind of right in the middle give you the kind of best of both worlds. You get a fairly low acquisition cost for the capacity, but also help eliminate those spikes in performance that are affecting applications. And eventually it's going to be a mix and match across all of them. Trying to get all those to display here on the screen at the same time, but it's really kind of the example of the different types of cars that put down there, right? A double-decker bus that's going to have a whole lot of people transferring at one given time, but not really at the highest speeds, all the way to, you know, maybe a two-passenger sports car that's going to be a faster I/O, low latency, but for less amount of people. So the use cases for Flash, and looking at all Flash, very good business use cases are databases, be it an OLTP, an OLAP for analytics, or desktop application services where you see a lot of people accessing the same thing at the same time. Bootstorm, stuff like that, and those desktop application services that we see Flash filling that need, as well as online gaming, very, very latency impacted applications like that, and technical computing. And as we move over to the hybrid array, you see a lot of overlapping with the OLTP and the OLAP. So depending upon the type of workloads that you're seeing, a hybrid array might be able to handle that just fine, even down in the applications. But then as we get into things like collaboration, file services, web, blob imaging, those types of things don't really require the all-flash type low latency, huge impact to the latency, but also kind of get the advantage over having just spinning disk drives, where you might have a larger delay, and that delay and that latency kind of trickles up. So hybrids in those environments make a lot of sense to try to eliminate the slower spots you see in the disk IOs. Some of the primary drivers for all flash, now this is all flash, not the hybrid, application acceleration. So the business critical apps that are really impacted by latency really drive for all flash arrays. I/O efficiency, and this is something that's been around for a long time in the storage industry, where you'll see that if you have a really high I/O requirement, you have to put a lot of spinning disk drives to get you enough I/O for the overall application to perform. Well, with that, you typically have a whole lot of extra capacity that's deployed in those environments to be able to get the IOPS. So you're really sizing to the IOPS versus the capacity. So to drive that efficiency back, if you use these flash media, you're going to get a whole lot more IOPS per gig, and it kind of flips it over into an IOP-driven sizing versus a capacity-driven. And we'll see some more on that in the next coming slides. Then also I/O offload. So all flash arrays, and we'll talk about the differences of those in a little bit as well, but some of them are just made for speed. So they're just disk drives put together, and all the fancy functionality is typically offloaded to something else. So you just have an array that's just a bunch of disk drives, just a bunch of flash drives in there to sustain a very low I/O, very high I/O, low latency environments. So that kind of offloading from the storage subsystem directly to just disk drives performing to optimal. So you'll see that I/O offload come up a little bit too in my next slide, where you kind of take the functionality away from the disk subsystem and leave that to the virtualization layer or other layers, and just concentrate the disks on it as fast as possible, and making sure that that I/O offload is just this subsystem for the storage versus in the application layer. Not all flash is the same, kind of a play on words a little bit there, but really when you look at an all-flash subsystem, if you're designing it for low latency, it's going to be your focus, right? Lightweight data management applications, low footprint, low power usage, and really designed for the scale-up type architecture. Not really meant for getting all the efficiencies and everything out of it, just focused on keeping the latency low. Versus the optimized for latency on that side of it, balanced for performance and features, so a robust data management, built-in efficiencies, so things like deduplication and thin provisioning and encryption and all those things can be built into an all-flash system as well, but it's more designed for efficiency than just for the absolute lowest latency as possible. And this is more of a scale-out design where you can put multiple versions and go wide with it versus the scale-up for the latency option where you typically see larger systems deployed depending upon the amount of IOs you really do need. And determining the right media. So what we'll see here is the cost per gig is no longer the best measurement on its own. I've kind of alluded to that earlier a little bit in some of the sizings. So what we're seeing is that, what are your IOPS per terabyte requirements? That might be a better sizing question for a lot of these environments, and it really helps you determine the right media. But then also, what are your latency requirements? So in the past, it used to be just, hey, how much capacity do you need? And then what's the cost on that on a per gig basis? And what we're seeing now is we get more into the application to figure out what really do we need from an IOPS perspective, and really what are the impacts of the latency. And this is going to determine if it's going to be an all-flash system that's just designed for the absolute optimal low latency throughput, or if we get into something that a hybrid model can handle, or it might even be an all-disk, right? All these questions kind of lead us down to different solutions when it comes down to it. So in the IOPS per terabyte, this is going to be measured in kind of a, I guess it's obvious when you look at it, but you might not think about it first, right? So on this graph, we're going to have performance going up and capacity going off to the right. And the IOPS per terabyte is actually wherever you land up on this little graph. For instance, if you look at the very top, you're going to have the very most IOPS per terabyte. So you don't have a whole lot of capacity, but you have a whole lot of IOPS, very much a flash type environment. And then across the bottom, from a capacity perspective, the larger capacity you go to, typically your IOPS are not as much of a requirement. This would be for the long-term storage kind of thing. So you can have a whole lot of capacity with not a lot of throughput and IOPS behind it. So flash is the best offering for the high IOPS and low capacity. And then on the other extreme, physical spinning disk drives are probably the best on a per gigabyte. And then there's the whole area in between, right? In between there, it's going to be kind of a mixture between SSDs and spinning media all the way up to an all-flash type array. The right solution was balancing performance and capacity. So what we're going to see on this graph, the same axes, right? You're going to have the performance going up and the capacity up to the right. Traditional hard drives give you that capacity with the less performance, very much like the previous graph. But then we see the hard drives with the acceleration. So the hybrid arrays kind of give you a little bit of a bump in performance, or actually quite a bit of a bump in performance as it goes along the capacity scale. But if you stay all the way to the left, you're going to see that's where the all-flash is. And you can get some capacity out of it, but then it's really geared towards the performance. Now we still have that white area in between, which we're going to call the area of contention, I believe, when the slide builds. Hit it again. So this area in between is really kind of the gray area. Do you expand the flash, or is it more on the, there we go, the zone of contention there? Is it closer to the flash acceleration, or is it closer to the all-flash fast? I'm not sure if everybody can hear me right now, but I'm getting some messages that audio is not doing so well. So the zone of contention down the center is really the question between the all-flash and the hybrid, and where those two can come close to each other, potentially even overlap. So data placement is a challenge in a hybrid array. So now this is specific to hybrids. And what we're hoping for here is that data should be fast when it's hot and low cost when it's cold. I mean, that's the ideal. But there's some logic and algorithms and everything that goes along the way to make sure that that actually happens. So you're going to see that there's a lot of work that goes behind the scenes to make sure that the data is placed in the SSD in a hybrid when it needs to be, and then on the spinning platters when it doesn't need to be. The challenge there is understanding when data needs to be where, or at what point in time it needs to be moved around. So an example of that on the next slide is going to be the virtual storage tiering. And this is specific to data on tap. Here's one example of how people can accommodate that, having the right data in the right place at any given time. So it's a really efficient use of flash, right, because you don't have to have everything in all flash, but when you can make sure that your hit rate is there so that when you do need the data, it truly is coming off the flash. Very simple to install. It's just kind of, you add the capacity to the disk pool, and then it uses it, and it does it itself, managing, and it provides for non-disruptive operations. It's useful even when you're moving data around or controllers and taking hardware out, putting different hardware in that is associated with the data. The actual flash stays consistent with the data in the overall pool. And then real-time responsiveness. This data is moving around, and when the operating system is requesting it is when all the data is made sure to be in the right type and the right tier. NetApp has some other offerings as well as another example of flash in the industry. So multiple approaches to flash. So there's different versions depending upon what you're trying to accomplish. We went over the questions earlier as to, is it going to be sized by IOPS or capacity, and even to what type of cache do you need to support that type of a workload. So with the multiple offerings that NetApp has and the complete portfolio for the enterprise, you get into different innovations that they have with the data management. They've been doing it for a long time, and they do it very well. And then investment protection, as you can add flash to systems, you can add different types of flash, and you can move data between different systems with flash without disruption. And then services around all that to make sure everything goes clean and clear. From a NetApp perspective as well, they have shipped a ton of flash with over 200 flash-related patents. 70,000 controllers have shipped, and of those, there's been about over 3,000 of them that are flash only, so all flash controllers. So with that, kind of a little blurb from a NetApp perspective at the end, the overall flash technology, and then getting into some Q&A after talking a little bit about NetApp. Are there any questions out there that people may have?
Thanks so much, Pete. There actually is one question from Derek. Is there a difference in managing the different types of arrays?
That's a question that could be a presentation on its own when you think about it. But on an array specific, and if you think about only an application, I'll say no. Right? If it's a flash array or if it's a hybrid, on a single application perspective, there is definitely a difference. But then as you go beyond that and you start thinking about an entire infrastructure, and you have maybe some flash here and some all disk drives here, and there might be different manufacturers and different tiers, you can get into a great amount of complexity with different tiers in your environment. So finding a way to manage all those tiers, if you go with a single manufacturer, it can be a lot easier because they can integrate with each other inside of your different tiers. But if you think about having multiple different manufacturers, it can be a great challenge, and even just the different tiers. So kind of leading off of that, I can kind of go into where does it make sense for all flash. And if you're a smaller environment, and just kind of throwing a number out there, definitely under 100 terabyte type environment, it might be better for you to go with an all-flash system and not have to manage all of the tiers of storage. That net difference in price might not actually pay for the savings that you're going to get by putting in the different tiers of capacity. Kind of an easy button for the overall. Just go with all flash, put it all in there, and never have to worry about it. Now, if you're multi-petabytes, that definitely is not the case. So there's kind of that line in the sand at some point from a justification of, do I go all flash, or do I need to architect really for what the I/O patterns are going to be for my environment specifically? And the management costs definitely come into play there. You can save some management costs if you go with a single solution for everything. And as Gartner and IDC report, the management costs outweigh the actual acquisition cost of a lot of these things, a lot of stores in the industry. So you can look at it that way, that just the acquisition cost might not pay for the difference in management, but the overall lifetime of the capacity that I'm going to own and the ease of use of the capacity might justify a higher acquisition cost up front. And those are always a challenge to get past the accounting people in the world, but it's another thought. It's another aspect of the total cost of ownership. Great question, and hopefully I didn't allude too much and go down too many paths on that. But any other questions pop up since then or not?
Yeah, there actually is one more from Christopher. What do you think about the approach NetApp takes with something like flash pools that almost act like PAM modules for write operations versus vendors who do more automated storage tiering where data is moved from spindle type to spindle type depending on its access profile?
It's a good question, very specific to NetApp, but the idea there is that NetApp has developed a way to make it easy to move data between them with their flash pools, similar to what they did in the olden days with their PAM cards. Makes it very easy for users. Users don't have to worry about it, and the cache hit rates are incredible in those environments because they know the data, the operating system does. You get into the general manufacturers that will put something in place to pull the data at different points and move it between the tiers. You'll actually see a high amount of IOs just specific to moving data around in the background, hoping to get the right cache hit rate. So you see the hit rate is much better from an integrated solution like the reference one from NetApp in the question versus the general one where you see a lot of data movement, a lot of things going on, and it actually can cause a lot of I/O that's unexpected just for maintaining and trying to predict. So two different ways of doing it. I'm not going to say one's better than the other, but if you can relate those back to the application, the better you're going to be. And just an example around that I tend to bring up is like a doctor's office, right? When you have scheduled visitors coming in throughout the day that you know that they're going to be there, if you can preload all that content into a higher tier so that your users of the data get a better user experience, that's great. If you don't have that luxury, like in an ER where you don't know they're coming in that day, less bang for the buck, and that's where the NetApp solution is going to, based upon the file system and the access through the file system, preload that stuff into cache. So kind of a better hit rate there. Good question, though. Any other questions?
It looks like that concludes the question portion. No others at this time. So with that, I would like to turn it back over. Thanks so much, Pete, by the way. That was awesome.
No problem.
I would like to turn it back over to Neil for a few important updates and offers from